8th grade, 7.4, comparing linear and nonlinear functions. Okay, you need to do your 2 warm-ups.
Can you check it?
I can look at them. So you're telling me whether relation's a function. What is the rule you're looking for?
One output.
If each input
Or
has
two outputs
one
can have the same
output.
input.
If each input has one input cannot have 2 different outputs.
Yeah, that's what I said.
That's the rule you really need to remember. So then you just tell me yes or no. Let me check on.
Okay.
Oh, hold on. I forgot to let me go back here. All right. So somebody tell me, what is a linear function? Nonlinear, excuse me. What is a nonlinear function, Josh?
A non-linear function does not have a constant rate of change.
Okay, so that's the biggest difference between linear and nonlinear. You've heard this before. Linear, it's a constant rate. Your slope goes, up 1 over 1, up 2 over 1, whatever. It's a constant rate of change. Whereas a nonlinear one, it's going to be wonky. It'll look like an S-curve. So let's do your first example. Does each table represent linear or nonlinear? Well, just looking at the table, you're not going to be able to figure it out without doing a couple quick calculations. So for A, what is the change between 3 and 6?
3. Like, it goes
Up 3, plus 3. So you can say plus 3. Okay, 6 to 9 plus 3, 9 to 12 plus 3. So now let's look at the Y. What changes between 40 and 32?
It goes down 8.
Down 8, 32 to 24.
Down 8.
So it is also a constant rate. Okay, so this would be considered a linear function because it does change at a constant rate. Each point changes the same. Even though the x's are plus 3s and the y's are minus 8s, it's still considered a constant rate of change. Okay, so now let's look at B. What is the change from the first x to the next x? Plus 2. What about from 3 to 5? Plus 2, plus 2, plus 2. But let's look at the y's. 2 to 11 is what?
Plus 9.
And 11 to 33.
Plus 22.
And then plus 55. So this changes more rapidly. If you were to draw this, your curve is actually going to be a very sharp curve. So this is a non-linear. When you hear linear, think line. Does it create a straight line or is it a curve? When you were to if you were to graph this one would have a curve. So it's not constant. So it's non-linear. Does that make sense? So this is literally all you have to do is just look at the tables, do a little math to see what the rate of change is.
Okay.
Does that help?
Yes.
All right, go do your try it 1 and 2. I'll leave this up in case anybody is still writing it. All right. So example 2, put this in your journals. Does each equation represent a linear or nonlinear function? So the cool part about algebra is you can look at one of these functions and immediately know whether it's linear or nonlinear. Can anybody guess what makes it linear versus nonlinear? Absolutely, if you can put it in slope-intercept form. So this first equation, can I simplify this into slope-intercept form?
Yes.
Yeah, I just distribute the 4, right?
Yes.
So then I get y equals 4x minus 4. Slope-intercept form is the form of a linear equation. So A would be a linear function. So now let's look at B. Can we rearrange this one at all to make it a linear function? You have 4 divided by x. Can I move the 4 to the side of the x or under the x? No. So this one cannot be rearranged. It's just, it is what it is. So this one would be considered not slope-intercept form. So it's not a constant rate of change. So it's nonlinear. It's going to be another curved graph. Okay, now I do want to write one more because I'm guessing they're going to ask it and they don't ever teach it. They just go, hey, here, try this tricky question.
Yeah.
So let me write one real quick. So what if I have y equals x divided by 4? Can I rewrite this? And we can put, at the end of it, plus 3 if that helps your brain. Can I rewrite this into slope-intercept form?
Yes.
Yes.
They're like, I believe she's tricking us. Yes, what's in front of this x? An imaginary 1, right? So could I write this as just the fraction y equals 1 over 4x plus 3, and that's perfectly in slope-intercept form? Yeah. So make sure you're paying attention. If x is on top, then yes, you can put it into slope-intercept form. If x is on the bottom, you may not. Because if x is on the bottom, you can't rewrite... ooh, that's an x. It'd be... This x has to be divided from the 4. You can't just separate it. The math is not the same. Whereas the math here is the same. If I have x divided by... Say x was 8. 8 divided by 4 is 4, right? If x is 8 here, 4 over 8 is not the same thing as 4 times 8. Because if I were to separate that, it'd be 4 over 1x, right? The math is different. 4 divided by 8 gives you 1/2. 4, this becomes 4 times 8, and all of a sudden that gives you a much bigger number. So see how the math is different if you separate them? Whereas here it's the same. Whether I put 1/4 times x or x divided by 4, the math is the same. Comprende? All right. So if the x is on the bottom, nonlinear. If the x is on top, you can make it a linear function. All right. Go. Go do, try it, 3 through 5. Okay, real quick, just look up here. So, number 5, y equals 1 minus x squared. See how you have x squared here? Anytime you have an exponent on your slope variable, whatever, that is going to give you, it's like a v whenever you graph it. So you're not... Anytime you have an exponent, you can just automatically know it's not nonlinear. You cannot have an exponent at all. I should find my graphing calculator and type this in, and you can see what the graph looks like. Oh, I think there's one here. Hold on. Math tools. Graphing calculator. Here we go. This will be cool. Y equals 1 minus x squared. Now how do I make it graph? Oh, thank you. See? Yes, go ahead. So see how it graphs it for you? By the way, yeah, this is the graphing calculator. Pretty cool. So, what's one of your other equations that you just did?
Y equals 4x over 3.
Over 3?
Yeah.
So see how, even though that looks funky, it is a straight line.
What about y equals 4 over x?
Y equals 4 over x. Are those nonlinear or linear?
Nonlinear.
Yep. Because 4, there's 2 possible answers for x. That's why they have these 2 lines.
Are we allowed to use graphing calculators?
Yes. I recommend you all go purchase a graphing calculator. You really don't need it till your sophomore year. So your freshman year, the ones I got you will be fine. But your sophomore year, you're going to want a graphing calculator. But there's an online. It's Desmos, this word Desmos graphing calculator. You can use the online version. Mrs. Hall will show you. She's awesome like that. Good. Any other? Isn't that kind of fun, though? You guys will know how to graph this stuff in the next few years. And you'll have a calculator that does it for you. I did not. I had to graph it all by hand. I sound old. I'm lying. I actually had a graphing calculator. I'm not that old. Okay, so now you're just looking at the graphs and telling me whether it's linear or nonlinear. So is A linear or nonlinear?
Nonlinear.
It's not a line, it's a squiggle. It's a squiggle, so that's nonlinear. What about B?
It's pretty
Think hard. It's difficult.
Yeah, that's a
I
really
know.
hard
I
question.
seriously can't tell if it's
So linear versus nonlinear. You guys got it? Good. Go do the next set.
Whoa.
Go. Example 4.
Writing this.
2 accounts earn different types of interest. This looks like 7th grade work. The table shows the balances of each account for 5 years. Graph the data and compare the balances of the accounts over time. This is exactly what 7th grade is doing. So for each year, you have account A. So here's your point: 0, 100, 1, 110, 2, 120, 3, 130, and so on. For B, 0, 100, 1, 110, and so on. So when you graph them, those are your points. Okay? So if I were to plot each of these points, this is what it would look like. Okay, so that's for A. Nice, consistent. This is simple interest. 7th grade, here's an example of simple interest. Look up here.
Yes, 7th grade.
7th grade? This is them making money. But here's the difference. If you have account B, this is compound interest. If you ever invest, get compound, because watch what happens when you plot these.
Oh.
All of a sudden, it takes a small curve, and I'm making more money faster.
Whoa! I learned things.
Do what?
Compound interest takes the money beforehand and multiplies it times the interest, whereas this one is always on the original. So compound interest makes you more money.
Okay. How would we put that?
Well,
But looking at these, is account A considered a linear equation? Yes or no?
Yes.
Yes. Is account B linear equation? No, because it's got a slight curve, right? Is that all we had to ask? Graph the data,
Yeah.
compare the balances.
That was the whole thing.
Oh, the balance, you make a whole lot more money with your nonlinear equation.
How do we put that on our thing?
I saw what Mrs. Cease did. Seriously, I'm good with that.
I want to say them for all of my explanations.
No, just this one. I'm allowing you for this one. You're welcome. All right. So then you have. That's what Missy said. 2 more questions, and you're done, 8th grade.
See if any help.
Okay, so for number 12, let me go to number 12. It tells you a video blogger is someone who records a video diary. We knew that. A new website currently hosts 90 video bloggers and projects a gain of 10 video bloggers per month. If I increase 10 per month, is that a linear growth or nonlinear?
Linear.
Linear, because it's equal each time. Let's look at this table. We started with 90. On month 1, what did I go up by?
97.
7. That's not 10. What did I go up from month 1 to month 2? 3.
13.
That's 13.
13.
People,
Good job, Matt.
That was the first one.
Okay, and then, so that went up more than 10. What about from 2 to 3? Okay, so this went up in a nonlinear equation, right? It increased more than the constant rate of change. That's literally all you have to tell me.
It went up.
No, it did not increase at a constant rate. It increased more rapidly. It's nonlinear. It's the long and the short of it. It actually increased exponentially is the word you could use.
Exponentially.
Yes, you better watch out.
You should just turn those in.